So this module 4, it is all about access control list concepts. Uh, the areas that you're going to go through. We have the purpose of access control list, then wildcard mask guidelines, and then the types of IPv4 access control list. What's the purpose of the access control list? So the ACLs, or access control list, access control list is a series of iOS commands that are used to filter just uh, a list of rules, list of statements, and those statements, they have actions like permit, deny, and they are used to filter packets. So if the action is deny, that means that the package that matches that rule or that statement, it's going to be denied. If it's permit and the packet matches the statement, then automatically it's going to be permitted. So by default, a router does not have any access control list configured. When access control list is applied on an interface, then the router performs additional tasks. So once the access control list is added into the interface, then it means that every packet that tries to go through that interface, it has to be checked. So an access control list, it uses sequence, it uses a sequential list of permit and then deny statement known as access control entries. So these statements, they can be called entries. They can they can be called access control entries. So still those entries, they can also they can be called the statements. They can be called statements. So when network traffic passes through an interface configured with access control list, then the router compares the information within the packet against the entry, the access control entry, in sequential order to determine if the packet matches one of the entry. So this process is called packet filtering. There are several tasks performed by routers required the user access controllers to define or to identify traffic, limit network traffic. Several tasks performed by routers requires the access control list to identify traffic by limiting network traffic to increase network performance. So if the traffic is limited, then the network performance is increased or tends to be fast. Provides traffic control. The traffic is controlled, which one should go through, which one should not be allowed. Provide basic level of security for network. Filters traffic based on traffic type. Screens hosts to permit and deny access to the network service, the services that are allowed on the network. Then lastly, provide priority, which traffic should be given the first priority. So packet filtering, it can be done on two layers, and that is transport and then the network. Transport layer and then the network. On transport layer, of course, we expect to use the port numbers. Port numbers, for example, HTTP, you can use port 20, you say that. But when it comes to the network, we expect IP addresses only. But on transport, the port numbers. So packet filtering controls access to network by analyzing the incoming and outgoing packets and forwarding them or discarding them based on the given criteria. So packet filtering can occur on those two layers that I've mentioned, 3 and then 4. So Cisco router supports two types of access control list. Two types. So type 1, it's standard access control list, and then extended access control list. So for this one here, it only filters layer 3. It only filters at layer 3 using source IP addresses only. So it deals with source IP addresses only. But when it comes to extended, it filters layer 3. It filters at layer 3 using source or destination. So meaning that you can either use the source, you can specify the source, destination. Actually, here you have to specify the two, both the source and then the destination. In standard, you specify the source address, the source address. Then this one here, you can even go ahead to layer 4 using TCP UDP ports and then optional protocol type information for FINA control. The access control operations, So the ACLs define the set of rules that give added control for packets that enter inbound interfaces. So packets that relay through the router, and packets that exit the outbound interface of the router. So here, the access control list, it's in two directions. We have inbound and then outbound. They can be filtered before entering the router, or they can be filtered before the router forwards it. Note, access control lists do not act on packet that originates from the router. Any packet that originates within this router, it's not going to be filtered, but it can be filtered if it is if it enters the router and it's trying to, before it
Excuse me,
enters, or
sir.
if it is exiting the network. Yes, please.
Are you sharing the screen for me?
So when an access control list is added on is applied on an interface, it follows specific operating procedure. Here are the operational steps. Step number 1, the router extracts the source. So the router has to extract the source IP address from the packet header. And then the router starts at the top of the access control list and then compares the source IP address in the packet header with each access control entry. So the source IP in the packet header, it has to be compared to each and every entry in the access control list in the sequence order starting from the first one, meaning that the order it matters. When a match is made, now the match, it can be deny or permit. So the router carries out instruction. What is it saying? Is it permitting or denying? So if it's permit, or it is going to actually operate the way the action instructs. Okay, it will operate according to the instructions that are in the entry. If it is denied, it is denied. If it is permit, it is going to be permitted. So if the source IP address does not match any entry in the access control list, then the packet is discarded. It's going to be discarded because there is what we call implicit deny. Implicit deny. So if the source IP address in the packet header does not match any entry in the access control list, then that one is going to be worked upon by implicit denial, and it is blocked. So the last N access control list, this is always implicit deny that blocks all traffic. It is hidden and not displayed in the configuration. So any access control list must have at least one permit statement. Otherwise, all traffic will be denied due to this hidden implicit deny access entry statement. So here is the packet tracer. You will complete the following: verify local connectivity and test access control list. The connectivity, and then you test. Then remove access control list, and then repeat test. Verify local connectivity, test access control lists, and then you can remove and then repeat the test. If you have access control list, what is going to happen? If you remove, what will happen again? So we have what we call wildcard mask. Wildcard mask. So with wildcard mask, it's just the opposite of a subnet mask. So if I have 255, 255, 255.0, the opposite of this should be 0 here, 0, 0, then 255. So this is the wildcard mask for this subnet mask. Okay. So in other words, you just flip. Here we have 8 ones, 8 ones, 8 ones. Here we have 8 zeros. These are 5, 6, 7, 8. So here I will flip 8 ones to zeros. I will get a 0 here, get a 0 here, get 8 zeros here, 8 zeros, 8 zeros. But when it comes here, I would have to flip these zeros to ones. And if I convert the ones into by decimal, that is 255, then this other n 0, 0, 0, 0. So wildcard mask uses the following rule to match binaries, ones and then zeros. So wildcard mask bit 0 matches corresponding bit value. It matches. Then where we have 1, it ignores. So where we have ones here, it means that this is the portion that is going to keep on changing. You see this, where we have this, the ones. And then where we have the zeros, these ones here, matches bit value in corresponding. That this one here, it's going to remain constant. The same way when we do 255, 255, 255. That the portion that corresponds, the octant that corresponds with 255, they remain constant. But now when it comes to wildcard mask, the octant that corresponds with 255, it's the one that is going to change. That's what they're saying. Ignore the corresponding bit, because for it, it's going to keep on changing. It's going to keep on changing. So if you're still confused on this, then I advise you can actually go through. I think the first two recordings still I explained that. So here we have the sample of the wildcard mask. When you look at this, 0, 0, 0, 0. So if you have a network address like 192.168.1.0, then it means that actually, okay, this one here, .1, it means that this, where we have the 0, they have to remain constant here. Whatever that we have here, it remains constant. That is it. That is it. So when you look at this, it matches all octets. That it has to be that. The same way when we say 255 slot in subnet mask. You remember where we have /32 under interfaces? That is the exact frame. Now we have this one here. We have this one here. So with this, it means that this, it's the octant that it responds with, it has to remain constant, this remain constant, this remain constant. Then on these, some bits, they have to remain constant. And those bits that remains constant, there are two, which are these. But the ones that total to this 63, those ones are subjected to change. Meaning that in this network, in this group, there are 63 IP address. That is what it means. 63 address. Here there is none. Okay, it's one. Just one here. Here there are 63. And then when it comes to this one here, this wildcard mask, it supports 15 addresses. Actually, not 50. This one here, it supports 64 because there is always a network address. The network address. So this is 64. This is 16. And then when it comes to this one here, how many?
249.
Sorry?
That one, 249.
240? Which one?
9.
It's not on the record. So here idea, it's not supposed to be this, it's supposed to be 0.0.0 then dot 7, and this side it would give us 0 0 0 5 zeros and then 3 ones like this. So this is wrong. Even when it comes here, match the first 3 octanes. So first 3 octanes. You see, we match the first 3 octanes, those ones, and then ignore the 6 leftmost bits. 6, they are supposed to be left. This is wrong. So match the last 2. No, this is wrong because we cannot match. Because if you are ignoring, ideally, we're ignoring this and then this and then this, you are not going to skip. We are not going to skip. So ideally, these other 1, 2, 3, 4, 5, still these, they have to be matched. And then these, they are ignored. So meaning that those are the 8. The 8, since we have this, then they have to be 8. They to be ignored. So you match the first 3 octants and then ignore the last octant. You see now where we have the ones, we ignore this. So you cannot ignore first and then you match last. That one is out. Okay. Now here, wildcard mask to match a host. To match a host. To match a host. So if it's a host, then it means that to match a host, it means a host. If this is the computer, we expect one address, for example, 192.168.1.1. So this is a host, just one. So the wildcard mask that matches this, it's 0.0.0.0. Because this, if I are to give it a subnet mask, it would be /32. The subnet mask that matches a host here, it is this. So the vice versa of this, it's 0.0.0. So meaning that you match this, match this, match this, and then this. That is what it means, and it is here. This is the IP address, and then this is in binary, and this is the wildcard mask. It's the wildcard mask. Here, wildcard mask that matches IPv4 subnet. The subnet. So if it's a subnet, now it is this one here. Of course, it's one, this one here. The subnet mask, it's 255.255.255, then dot 0. So the vice versa of this, the reverse, it's 0 here, 0, 0, and then 255, which is this, what you're seeing here. Wildcard mask that matches this, the range, the range. So our range, it's here. We have a 0, 192.168.16.0, then 17. This is 16.0, 17.0, up to 31. So meaning that we have 192.168 dot, the first one 16.0, and then the last one we have 192.168 dot, here the last one it is 31.0. So we need the wildcard mask that supports this range. That supports this range. We're going to summarize, and as we are summarizing this, we don't need to stress our thoughts. So even if I change from 16 then to from 16 here, what you're seeing here, up to 31. And okay, if I list, let me use that one. If I list 16, okay, there is 17. I go into 19, then 68, then dot 18, dot 0, up to 31. So it will remain the same. It's not going to change that. So we're not, without wasting time, what I'm going to do is just to have the first and then the last, 31.0. So I'm going to ignore this, because even if I convert them, they will give me the same. They'll give me the same. So I will just convert only this. Convert this. So 16, I'll just come here, say, because we expect 128, then 64, 32, 16, 8, 4, 2, then 1. So I'm going to convert 16. 16, I have the 1 here, the rest are zeros. Then 31, of course I have to look for the numbers here that total to 31. If you want, we can actually keep on. Now 17, you look for 17. You look for 17. Now 17, it is 1 and then 1 here. The rest are zeros. If I want 18, it is 16 plus 2 here. The rest. I hope we are following. Are we following, guys? Then 19, it is this and a 3. A 3, it's 16 plus 2, 18 plus 1. The rest. Okay. Then if I want 20, it is 16 plus 4. The rest is yours.
So are you converting to binary, or I don't seem to understand it?
Yes? I'm trying to come up with a summarized address. And how are you going to come up with a summarized address? You have to convert all the addresses that you have, convert them into binary. And if you have to convert all those IP addresses, remember how many are they? From 16 to this, these are 16 IP addresses. Joseph, where are you going to get time? If I'm to sample you, that a 32, we need 16 plus 8, that is 24, 24 plus this, that is 28, 28 plus this, it is 30, 30 plus this is 31. So it will be 1, 1, 1, 1, 1. But this is a 32 here. I've skipped some because this one here it was 20. This I've skipped some. So what I wanted to drive to, or drive at, it is once you're able to convert your networks into binary. Now we're going to compare. We're going to compare that what we have so far here. You see, okay, here we have a 0, 0, and then a 0 here. So we're going to compare actually to come up. Anyway, we're going to compare first using the AND, whereby the combination, it's only 1 and the 1 that gives you a 1. The rest of the combination, they give you 0. So here, even if I had converted all these other numbers, because this was 20, then 21, 22, 23, 24, like that. So they were not going to, on this, here we're going to have a 0, here a 0, here a 0, because now since I'm seeing 1, 1 slouch here still, even the ones that I've skipped, there is a 1 here, because it needs, or 16 is part. So here we give it a 1. Then the rest here, as you can see, there are no other lines, no any other column that will give you a 1. So these other ones are also zeros. Then at the end, you will find yourself having this octant as 16. So it would be 192.168.16.0 as our network address, but now we are left with subnet mask. What would be the subnet mask? So the subnet mask, we are going to actually look at, you keep looking at the bits that are matching slouch. So the 16 addresses, because here we have starting from 16 up to 31. So you compare. Now here they are the same, they are matching. Don't mind about the zeros and 1, but they are matching. Here it's matching, here it's matching, this it's matching, then this one here it is also matching. But when it comes to these other ones, starting from this, they are not matching. So the first, where we have where we have this, as you can see, here we expect 8 bits that are matching, 8 bits that are matching. But when it comes to this one here, the matching bits, we have 1, 2, 3, and then 4. So the matching bits here, they are 4. And then here we have our 0, but still 8. So here, if you are to give it the prefix here, it would be 8, 8 plus this. So this is 16 plus 4, 20. 20. I think I will actually record something short about IP address summarization, how to summarize IP addresses. I will do that for you guys so that you can pick.
Okay, that's very important.
I will do that because I don't want you to leave you in space hanging. I will do that separately. Now, with this one here, it will be /20. The moment you have the subnet mask, then there you can get the wildcard mask. So the subnet mask for this one here, it would be we have this 255, then 255, then this, since this is 4, it is 240, then .0. So it's wildcard mask here, it's the vice versa. The vice versa. This is Victoria. Victoria, it is okay. You can unmute you. Sorry. You get the the reason why we did all this, not to question where is this one here coming from as the wildcard mask. So get this one here, then subtract the subnet mask that we got from this. 255 minus 255, 255 minus 255, 255 minus 240, 255 minus 0. So you get this. And that is what we have. What you have here. So the addresses, it's this range. From this one here, as you can see, it's this, the starting, and then the end is this. You can decide to work out with only these ones here. It will help. You decide to work with this. Still, we can try it out and see how easy it's going to look like. That we have 192.168 then dot 16.0, and then the other one we have 192 manage. Okay, 192 then 168 Here we said this 0, 0, 0, and then 1. Then this, oh, sorry, 1, 1, 1, 1, 2, 3, 4, 5, 6, 7, like this. Then here is 16. And this side we have a 0 here. For this, I'll just, so for 16, it is 0, 0, 0, then 1, then 0, 0, 0, like this. So here it's 1, then, sorry, again, I'm making a mistake, and then 1, 1, 1, 1, dot 0 there. So here, of course, they will remain the same. Here we expect 192, then here it's 168, and then when it comes to this one here, it's only this that matches, and it's a 16, so it will be 16 then dot 0. So this is our network address. Then in case you want the subnet mask, we're going to count the matching bits. So here we expect 1, we expect 8 ones here, 8 ones, and the matching bits here, as you can see, we have this one here, this, second, third, and then fourth. The rest are not matching when you look at this side. So here we have 8, 16 plus 4. It gives us 20. And our subnet mask, it will be 255, 255, then dot, here they will have 4, then dot 240.0. Our wildcard mask, it is 0, 0, 15, then 2, 5, 5. Okay. So wildcard mask calculation, I don't need to go through this. This is what we've been thinking about. Then we have wildcard mask keyword. Keyword. So in subnet mask, we have these two. That if you have 255, 255, 255, 255, this, it simply means that that exact host. Then if you have 0.0.0.0 in subnet mask, it means all the hosts. Actually, this one here, it's all the network. Any network. Let me use all addresses. All hosts. Now, in wildcard mask, it's going to be opposite. That if you have this, that means host, then it means that this, it means host. Where we have the zeros here, then it means that it's going to be 255, 255, 255, 255. That means all hosts. So in wildcard mask, where we have the zeros, we can replace this with host. And we can replace this with any. So instead of you typing 255, 255, you can replace this with any. Instead of you typing 0.0.0, you can replace it with host. That is what it's saying here. Guidelines for access control list creation. There is a limit on number of access control lists that can be applied on router interface. Eh, number of access control lists. You're not going to keep on creating. No, there is number of hosts. An example, dual stack, that is IPv4, IPv6. IPv4, IPv6 router interface can have up to 4 access control lists applied as shown in the figure, specifically for router interface. So on this, we have our router here. For this direction, on this, I cannot have IPv4 in and then have IPv4 then out. That one, it cannot happen. But I can have IPv4 in and then I have IPv6 out. This one here, it is allowed. It's allowed. So per interface, we expect one direction, the access control list in one direction. If you are to have two direction, then they will actually be of different version. Different version. That is what it is trying to check. That you can have IP here, you can have IPv6 inbound. If you have IPv4 inbound, then you cannot have outbound. That one, it can't happen. But you can have outbound if it is version 6 and you have two of them. So look at this. Note, access control lists do not have to be configured in both directions. The number of access control lists and their direction applied to interface will depend on the security policy of the organization. So here we can only have one direction. If you have to have two directions on the same interface, they should be from different IP version, different versions. So the guidelines here, if you to have them, using access control lists requires attention to detail and great care. So mistakes can be costly. So to avoid the mistakes, base access control list on the organization security policy. What does the organization organization policy say about the access control list? So based on that, so the benefit will ensure that you implement organization security guidelines, then write out what you want the access control list to do. So what are the targets? Write the targets before you write the access control list. Then use the text editor to create. Use text editor, you create those access control lists, edit them, and then you can save them aside. And then you keep retrieving them anytime you want. Not just you to have a sketch within them or onto the operational network. Document the access control list using remark. So as you're stating those access control lists, you can give them description, that every time you look at the description, you know what the access entry is supposed to be doing. And then test the access control lists on a development network before implementing them on production network. So before you have the access control list on the production network, first have a demo aside and you see whether it is going to achieve your target, your objective. If not, then you can re-edit it before you implement it on a production network. Types of IPv4 access control lists, we said there are two, where we have the standard access control list and then extended access control list. So with standard, it permits and denies packets based on the source IP address. Only the source IP address, it is what is stated in those entries. But when it comes to extended, we can use source and destination IP address, or we can use the protocol type with source destination, both TCP or UDP port numbers. So the numbered access the numbered access, we have numbered and then named. So we said the types we have two, standard and extended. But these ones here, they can be numbered, these two. They can be numbered or named. So numbered and named, they are not types. So you need to note that. So here we have the numbered. Numbered, we have to use the IDs. The access control list now are from 1 up to 99. 99. Or from 1,300 to 1,999. So here, as you can see, you can say access list, and then you say, so if it ranges from 1 up to 99 or 1,300 to 1,999, then this is standard. This is a standard access control list, and they are here. We have from 199, it's standard. We have 1,000, so 100 to 199, it is extended. Or we can go for 1,300, 1,999, it's still standard. Or from 2,000 to 2,699, it is extended. Yeah. So we have the named, the other one was numbered. Here it is named. So the named, we have to use the names. So it's IP access list X. Oh, because anyway, now this is extended instead of okay, the other one, it was number but still standard. The other one, anyway, this one here, it was numbered but it cuts through because it was not saying that it's standard or extended, but we were actually projected with, as you can see, we have standard. This is standard here, this is extended. Now when it comes to named, we can actually, on this point here, IP access list, you can say standard or you can say extended. The moment you deal with extended, then you have to work with both the source and destination IP addresses, or actually together with source and destination port numbers. See? So that's the reason why you're seeing here we have a port, as you can see here, we have TCP, we have both source, this is the source, and then this is the destination, and where we are saying any, I explained the concept of any, why do we need any, or what does any represent, and then the port. This is the port, the service FTP, the FTP. So here you just search, because now this is the name, and it can be anything. Here we have FTP filter, meaning that the name, it carries meaning, or it makes sense. Don't just create any name. Any name. So when you look at the name that is used, it makes sense what the access control list does, or what it is to, or the role that is to be played by the access control list. Then where to place the access control lists? So we have two types. So forget about numbered and named and numbered. So named and numbered, those are the mechanism to use. But the types, there are two, extended and then standard. For standard, you specify the source. So in the statements, you have to include the source, but the destination is not included. Then when it comes to extended, we have to include in the statements, we have to include both the source and then the destination. Now here, since the standard, it's with the source, then we have to attach or to press the standard access control list close to the destination. Because since the statement specifies the source, not the destination, then we have to press those access control list close to the destination. Close to the destination. I'll give you a scenario. We have a router here with this PC. So this PC is connected to this, and then this here, and then this. Is a PC, is a PC. So this is 1, this is 3, this is 2. Let's assume that we want to deny this PC from accessing PC3. So we cannot apply the access control list, the access control list on this router. One, it's going to lower the performance, and then again, it's going to prevent this PC from reaching the other networks that it would have, that it's supposed to be reaching, or that it was not the intention that was not intended to be blocked from accessing. So here, we have this PC. We want to block this PC from accessing PC3. So if we have it here, and the statement is saying block PC1, block PC1, the destination is not stated, meaning that this PC is going to be blocked from even accessing PC2, and yet it is supposed to access it. It's on the PC3 where it is blocked. It's on the PC3 that is not supposed to be accessed by PC1. But if you attach it here, then it means that beyond this network, PC1 here, it won't be allowed reaching those, it won't be allowed to reach those networks. But if you apply it on this router, then it means that here, PC1, it will be allowed to go through this router and head this side and then this side. And then when it reaches this router, it's when it's going to be blocked. But on this router, it's not going to be blocked at all. So it has to be close to the destination. So this is the right port, the right router where we can implement our access control list that blocks PC1 from accessing PC2. And then even the direction. So we're on this PC here, but which direction? Is it on this? Is it on this, or it is on this? Because now if you put it on this, it means that every packet that comes here on this interface, it has to be filtered. It has to be filtered. So the best interface, it would be this, that every packet that tries to exit this router heading to PC3, it should be the one that is filtered. But other interfaces shouldn't. But if you add it on this, then it means that it's going to lower the performance. The performance is going to be decreased, and then at the same time, there are those packets that are likely to be blocked, and yet they are not supposed to be blocked. Then, when it comes to extended, because for the extended, it allows the source and then the destination to be stated into the statements. So this time, it has to be blocked, or it has to be pressed close to the source. What does this mean? not to compete, because if you do that, you will actually not, you will have not created that room for competition. That the packet is not allowed to reach maybe what you are. Okay, anyway, let me just use. We have our router here, this, and then this. So we have this and then this one here. This is PC 2. This is PC 3, and then this is PC 1. So PC 1 is not allowed to reach or to access PC. This time, let me use PC 3. So PC 1 is not allowed to access PC 3, but is allowed to access PC 2. So we're not going to allow traffic to waste the available bandwidth, the available resources. And then when it reaches the destination, it finds there the access control list that is blocking it. It will have wasted or consumed or used up the resources, the network resources. So the best way is to be prevented close to the source where the packets are originating from. The reason why we did this in standard, it's because of the statement, it doesn't allow us to state the destination. But with extended, it allows us to state the destination. So it has to be blocked close. Close. The example I can give here is like you wasting your time, you travel miles and miles. Okay, let me use this like the online class. You travel from wherever you are, and then when you reach here, you're told, there is no class. There is no class. But in those scenarios where we have no platform, the social platforms that we can use to update each other, you will just walk, and then when you reach here, the class, you find the class locked. That is when you will notice that there is no class. But since we have those platforms, then we can communicate to each other in advance. There is no class, or the class it is online. Before you waste your time and your money, and then when you reach here, the class is online, or there is no class. That, I don't know whether it makes sense. Let me hear from some of you are there. Does it make sense, or does it?
Yes, it was.
Okay, so that is our extended. But still in our extended, there is what we call the dilection, that we expect our access control list on this router. But is it going to be on the exit or on the incoming interface? Get it? Exit on the incoming interface. So ideally here, since we are trying to block the traffic that may actually consume our virtual resources or the virtual network resources available. So we have to make sure that we prevent the traffic before it enters. So this is incoming, not outgoing. The incoming here. So we have to attach you created the access control list on the router, but you attach on a specific interface. So it has to be incoming. That as the traffic is trying to enter the router, it should be checked before the router accepting it, and then when it's trying to forward, that is when it is supposed to be checked. No. So, and again, on top of that, if you attach it on this, it means that it's only traffic that is trying to originate on this interface to be filtered. The traffic originating from, for example, from this direction here, it won't be checked on this. So it has to be checked only on this interface. So that is it. Factors influencing access control list placement. One, the extent of organization control. Eh? Placement of access control list depends on whether or not the organization has control of both the source and then the destination. So you have to make sure that you deal with the interface where you have access. Where you have access. You're not going to be on the client's network and then you want to control the interface that is owned by the service provider. No way. Bandwidth of the network involvement. Yeah, just to make sure that you try to control unwanted traffic onto the network to utilize the available bandwidth. Then ease of configuration. May be easier to implement access control list at the destination, but traffic will use bandwidth necessary. Easier of configurations. An extended access control could be used on each router where the traffic originated close to the source. Then the other one close to the destination, that is extended. So here we can discuss here the standard access control list placement example. The figure, the administrator wants to prevent. The administrator wants to where is my the administrator wants to prevent traffic originating in this network from reaching this. So it's 10 from reaching 30. Where is 10? 10 is this from reaching 30. Where is 30? Is this. So which one is the best router where we can place our access control list? Our access control list, not lists. Our access control list. Let me hear from you guys. Victor? Victor, are you there?
Yes, I'm here.
So where do you think we should press our access control list to block this network from reaching this network? So this is our topology here. Where should our access control list be pressed? Which router?
I think, just thinking maybe R3, because we are supposed to block traffic from entering.
Yes,
Block traffic before it enters.
Yeah, we are dealing with standard access control list, and access standard, we have to place the access control list close to the destination. So this is the source, and the source it is always stated in our access control entry, but the destination is not stated. That's the reason why we have to place them close to the destination. So this is our router. And on what interface? What interface? Because it also matters. We've pressed our access because we're going to create access controls on this router. But where should we place our access control list? Is it on this interface? Because the possible interface, we have this and then this. But which one is the best?
Interface S001.
001. Here, Victor, here you're wrong. Because remember, we are blocking. the statement, it's blocking this network. So meaning that once our traffic reaches here, the traffic reaches here, it's going to be blocked. And ideally, we want it to be blocked from accessing this network. Not this, should be allowed on 31, but blocked on 30. So this one here, it is not going to yield exactly what we want. So it has to be on this interface, on this, so that this traffic here is allowed on this other network. And then we have the direction. It can be inbound or outbound. Since it is on this, it has to be inbound. That's the reason why you're seeing this funnel trying to power in this direction. So this is, oh, sorry, it's not inbound, but it's outbound. It's trying to power out of the router. So this is outbound. But if it was the way you suggested here, it would be inbound, because the funnel here, it is trying to power inside the router. Inside the router. So that is our standard. Then we have the extended. That is what I was actually explaining. You can try to go through here to look at which one is the best router and which one is the best interface and which one would be the best direction. Then we have extended. Extended, we said it has to be pressed, the access control is to be pressed close to the source where it's originating from. So here the example, do we have an example here? In the figure, an example, company A, where is company A? It is this router here, the entire router. Company A wants to deny telnet and FTP traffic, so two traffics. We have telnet and then FTP traffic. Denying these two to reach company B. Where is company B? It is this. And then on company B, company B's network, which is 30. Where is 30? It is this. So we're denying telnet and FTP from reaching 30 network from 11. So which one is 11? 11, it's this network. So company A, network 11, this, from, under the traffic it is telnet and FTP from reaching 30. So meaning that since extended, it is the access control list is pressed close, pressed on the router that is close to the source. So the source, it is this, the router, it is this one here. So our access control list, they have to be pressed here. But now, on which interface? If we go for this one here, and our intention is just to filter traffic originating from this, it means that both this and then this, they will be filtered at this point. So we have to be actually be close. We go further and make sure that we are close to the source. So it's this interface that is close to our network here. And before this router accepts, because the moment it accepts, then it will be competing with this traffic. So let it be checked before it enters, so that this router, it is well capable of supporting these other traffic where they don't need filtering. Okay? So here it will be pressed on this and it is inbound. The filter, it is trying to power into the router, so it will be inbound. Before the router accepts the traffic, it has to be checked, and only traffic originating from 11, not 10. So that is it, and you can go through this. The reading talks about that, and that is the end of this session. It was